All right, so again, 0.25 raised to the fifth, probably is not getting a problem right. Probably not getting one question right, is 0.75. That happens 3 out of 4 times. So that would be 0.75 raised to the fifth power. On the probability of getting at least one problem right. So that's 1 minus probability of getting none of them right. One minus 0.7. I was just going to leave it like that because you can figure out what that is. So you're more likely to get none of the questions right than you are to get all 5 of the questions right. So I can just figure those numbers out. 0.25 raised to the fifth power. I got an E on there. Okay, so recall scientific notation. The answer 0.25 raised to the fifth power is not 9.7. Probably it's always a number between 0 and 1. 9.7 E negative 4. 9.7 E negative 4. 1, 2, 3 zeros. That's the probability of getting all 5 questions right, which is pretty small. Probably not going to happen, right? Let's find the probability of getting none of them right. 0.75 raised to the fifth power. 0.237. 23.7% chance of getting all the problems wrong. That's a lot more likely to happen. There's a 23% chance that would happen. And then at least 1, so I'm going to do 1 minus that. 0.76. There's a 76% chance of getting at least 1 question right. That's 1 or 2 or 3 or 4 or all 5 of them right. Okay. So that's kind of review is what we did there, and kind of 3.2, it was like blood types. Anything that has a probability of an event occurring, called probability experiments. But this is a special probability experiment. It's actually called a binomial experiment. If something's binomial, that means there's 2 possible outcomes. That means there's a success and failure. So probability, usually we're looking at true, false, the probability of having a boy or a girl, okay, 50-50. Probability of flipping a coin, 50-50. So we can have those probability experiments a little easier to work with, but that's not realistic. Okay, most probabilities don't happen 50-50. It's different probabilities have different outcomes. So again, probability experiment, the definition is right over here, and we're going on 4.2 today. We're gonna do 4.2 and 4.3. 4.2, we have 4 definitions of what it means to be binomial. Okay. So we have success and failure. I can define what a success is, and I use that language already. A success means we get a problem correct. We got the problem right. A failure means we got the problem wrong. 0.25, 0.75. N is fixed. What is N? We had 5-question quiz. Okay, N is fixed. Later on, we'll learn about a probability experiment where N is not fixed. Okay, so there's a couple of different ways to do some probability calculations when N is not fixed. So, but in this case, we had 5 questions. That's your sample size, or N actually is the number of trials. P is the same for each trial. So the probability of getting the first question right was 0.25. What's probability of getting the second question right? That's still 0.25. That has no bearing on whether or not we got the first question right. We're just guessing because we don't know the answer. Okay, and a lot of people, like, I've been teaching stats for a long time. I don't know anything about stats. Well, if you're going to absolutely guess on every question that's multiple choice, for example, the last quiz, number 3, if you didn't know anything about statistics, and it was a 15-question quiz, what's the probability of getting all 15 questions right? Well, that's real small, right? 0.25 raised to the 15th power. The most likely event to occur would be getting all the questions wrong. 0.75 raised to the 15th power. But most people will get more than 0 on a multiple choice quiz. So that tells me that you know something about statistics, right? A lot of people come in and I don't know anything. I never learned anything in statistics, or retaking the class. I had this other teacher and they're crazy and I didn't understand anything. Well, you know something about statistics, right? So it's making a little connection there. Probability of at least 1. Correct. So getting 5 right, that's at least 1. Getting 4 right, Correct. Got the first four right and the last one wrong. Incorrect. I'm gonna run out of markers today. So I didn't fill out the rest of the table, but everything that happens in here. I got first problem right, second problem wrong. Then I got the rest of them right. So that's four right. I got first problem right, second problem wrong, the next three correct. That's another way this can happen. So one of the things we want to do is calculate other probabilities. What's the probability of getting exactly one question right? What's the probability of getting in a 5-question quiz? I got 5 questions. What's the probability of getting one question right? Again, the answer is not 1 out of 5. Okay, there's 5 questions, multiple choice. So that'd be 0.25 and 0.75 and 0.25 and 0.25 and 0.25. I've got to multiply all those probabilities together. But it's a little more tricky than that because there's more than one way to do this. I could get the first question right, the second question right, third question right, fourth question right, the fifth one wrong. So there's actually 5 ways you can do it. There's 5 ways that you can get one question wrong. You get 4 right and 1 wrong. I get the first one right, or the second, or the third, or the fourth, or the fifth. Okay, so there's a lot of ways that can happen. And this is just like if there's any probability that happens 25% of the time. Okay, if you have a probability is 25%, follows the same path as this tree diagram. There's 5 people. 25% of the people in the class are left-handed. Okay, so if 25% are left-handed, we randomly pick 5 people. What's probably that 1 out of 5 is left-handed? Again, the rules of probability, it's not 1 out of 5. Okay, so it's a little more complicated than that. So that's why it's binomial. And the binomial formula, there's a formula for this that will give us the probability of getting exactly one question right. There's a probability of getting exactly 0 questions right, or getting all 5 of them right. Okay, so we're going to do this. We're going to do this as practice real quick. So we're going to take a little quiz and we're going to do this experiment. Okay, right now. It's actually a simulation of taking a quiz. So just on your notes, just number your paper 1, 2, 3, 4, 5. Okay, so now what you're going to do is take a imaginary quiz on binomial experiments, unless you already know lots about binomial experiments, which I don't think very many people do. But the quiz is multiple choice. There's 4 choices, A, B, C, D. So what you're going to do is guess the answer for number 1, 2, 3, 4, and 5. And then I'm going to give you the answers, and you're going to see if you're right or wrong, and we're going to see how many people get a 1 out of 5, a 2 out of 5, a 3 out of 5, and so on. So go ahead and do that real quick. It should only take you like 30 seconds to guess letters. A, C, A, B, D, A. Okay. Write some A, B, or C down, or D for all of these choices. Don't worry, it's not going to be graded. You're going to grade it yourself. It's not going to be a grade in the grade book.
What's your question?
You're just going to write A, B, C, or D for problem number 1. A, B, C, or D. You're just guessing for each of these. That's it. And then you're going to grade it yourself and see what your score is. So I'm going to give you the answers right now that I'm going to make up. So now you're going to grade yourself. Those are random letters there. Give yourself a grade. All right, so now, again, this is a simulation. We're simulating you taking a quiz. Okay, so you're just gonna raise your hand and you're gonna tell me how many problems you got right. So I'm gonna prove to you that you know stuff, right? Right now, this is evidence, this is proof that you know something. You can get 0 questions right, so 0 is a number in a binomial experiment. So we can always include n is fixed, there's 5 questions. There's success and failure, you either get a question right or wrong. Okay. Probability is the same, it's 25.25. Probability is fixed. X counts the number of successes. So a success is the number of questions you get right. Okay, so X, like if X equals 2, that means you got 2 questions right. We're going to calculate all these probabilities, theoretical probability, and this is going to be our simulated probability. Okay, so 0, you got 0 questions right. I'm just going to use, everybody got the answers? So I'm going to erase it right now. But I'm going to use this to do some calculations here. So we could get a 0 questions right. So you can just add a new column. We're going to do something different. Raise your hand if you got 0 questions right. You got a 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 people got 0 questions right. And 1 question right. 1, 2, 3, 4, 5, 6. And 2 questions right. 1, 2, 3, 4. And 3 questions right. 1, 2. 4 questions right. That's a 0. And 5. 5 questions right. Anybody get a 5 out of 5? I didn't think so. All right. Probably not going to happen. What's probably getting all 5 questions right? 0.0009. Okay, so what's that as a percentage? That's about 9. Well, pretty close. If I round it up, it was actually 0.0097 was the number. So if I round up, that would be 1 out of 1,000. So 1 out of 1,000 chances to get all 5 questions right. So theoretically, if I had 1,000 people, 1 person would get a 5 out of 5. Okay, so that's a theoretical probability, and it's pretty much, we just proved that this is much more likely to happen than that. Makes sense. But again, the probability is not 1 out of 5. So if I do this calculation, this is our simulated probability. So we have 22 people. We have 22 people. The probability of getting no questions right theoretically is 0.00, or I'm sorry, 0.237. Okay, we just calculated that. So I'm going to do 10 divided by 22, 0.45. Six out of 22 is 0.27. 4 out of 22. 0.18. And I'm rounding, it's okay. 2 out of 22. 0.09. Again, these are simulated probabilities. So what's probability getting 2 questions right? Well, simulated, it was 0.18. But theoretically, what would happen? I get 2 questions right. You get the first 2 right, and the next 3 wrong. Or I could get the first 3 wrong, and the last 2 right. There's so many different ways this can happen. So we have to count the number of ways this can happen. And in order to count the number of ways that this can happen, it's called a combination. And we learned all about combinations. Hopefully we did in chapter 3.4, using the rules for combinations and stuff like that. So what I'm going to do is this is a simulated probability. I'm going to find a theoretical probability. We already know what this one is. Getting 0 questions right. That is 0.00, or I'm sorry, getting 0 questions right is 0.237. 23% chance. This follows a formula called a binomial probability formula. So I'm going to put the formula up here for binomial experiment. And it's going to be a little bit different than the formulas in the textbook. They have an X. I'm going to use, actually I'll use X. I'll write down what's in the book, page 203. on page 203, we got the formula. So probability of X happening. So X again counts the number of successes. So if I want to find the probability of getting none of the questions right, X would be 0. So it goes like this. And CX, that just counts the number of ways something happens times probability of success. And don't worry if you're not mathematically inclined. This formula is going to get a little crazy, but our calculator will do all for us, okay? And then there's a Q. In the book, they use a Q. I'm going to use a different thing. Q is 1 minus P. Whenever you see Q, that's 1 minus P. So this formula will give us these numbers. This formula will give us the probability of getting 1 question right, and 2 questions right, and 3 and 4. So it gets a little crazy. I know it's really high level math here, but again, we'll be able to punch it into the calculator quite easily. I'm gonna do the formula for getting none of the questions right. I'm gonna erase the tree diagram because we don't really need it right now. We'll do another tree diagram in a little bit. So find the probability of getting all 5 questions right. So that is here. That was 0 or 0.0097. I'm going to use the formula to do this thing. X is 5. Probability X equals 5 is actually a notation that I'll use. So N is 5. C means combination. X is 5. So right now I'm just plugging numbers in here. X is 5, N is 5. P is probability of success, which is 0.25. Again, X is 5. Okay, and here you go. P is 0.25. What's 1 minus 0.25? 0.75. Thank you. And then 5 minus 5 is 0. N is 5, X is 5. So 5 take away 5 is 0. So I just plugged the numbers in just now to the formula. This 5C5, I can do it on my calculator. I can do the whole formula. I'm not going to do it. I can do 5C5 on the calculator, but I'm going to tell you what the answer is. It's 1. There's only one way. This tells us how many different ways can we get 5 questions right. Remember the tree that I just erased? Okay. Get 5 questions right, it's 0.25 raised to the 5th power. There's only one way that we can do that. So this right here is 1. This counts the number of ways of having success. 0.75 raised to the 0 power is 1. Any number raised to the 0 power, a 0 exponent. Have you guys seen that before? Having 0 as an exponent. If you don't know, punch any button into our number into the calculator. 7 raised to the 0 power is 1. Any number raised to the 0 power is 1. So this right here is 1. This is 1. So I get 0.25 raised to the 5th power, which is 0.00097. I got the exact same thing. So I calculated this using the multiplication rule. Calculated this using the formula. The formula gives us the exact same thing with the multiplication rule. So there's 2 ways to do it. Like I mentioned, copy and paste on the computer with Microsoft Word, right? I'm going to right click, copy, paste. Okay. Or I Control C, copy. Okay. So there's 2 ways to come up with these probabilities. What's probability of getting none of the questions right? Okay. I got none of them right. Okay. Where's it at? 10 people got a 0 in this classroom when they guess. Probably that happening. Well, that's when X is 0. 5C0. 5C0 is 1. Just like 5C5, they're the same thing. 0.25 raised to the x. 0.75 raised to the 5 minus 0 is 5. So there, this is 1. This is 1. 0.25 raised to the 0 power is 1. I get 0.75 raised to the 5th power, which is 0.237. So I'm just gonna list right over here the actual probability. So this is simulated. We could write the word actual or theoretical. The theoretical probability is probability getting no questions right, 0.237. Probability getting all of them right. That was 0.00097. So the big question is, what are these probabilities? Well, the formula will give it to us. So I want you to sit there and think. You're learning something new. You're learning a new formula. Plug in when x is 1, probability x equals 1. And it's still 5. There's still 5 questions. Find the probability of getting 1 question right. So that would be x is 1, 5C1, 0.25 raised to the 1st power. 1 minus 0.25 is 0.75. 5 take away 1 is 4. So that's the formula. See if you can punch that on your calculator. In fact, you could probably use any calculator for that little calculation. You might need to write it down to come up with the probability of getting 1 question right. I gotta go look for mine. Oh, so the raise to button, I never mentioned that. Raise to is this little button on your calculator. You do times and times, you press this button. That little button means raise to. Raise to the fourth power. 0.3 something. Yeah. 0.32. 0.374. Yeah.
Doing it wrong. 0.395.
Okay.
Yeah, that's not true. Yeah.
So if I go 0.75 raised to the fourth power, I'm gonna press enter. And make sure you follow order of operations. 0.25 times 0.25.
And it's weird because I get the same answer whether or not I put the exponent
0.395.
in the
Okay.
parentheses or outside.
All right, so I got, yeah, 0.395. I'll put it right over here. Probably x equals 1 is 0.395. No, it's a little bit different. We had more people get no questions right than we would expect for one question right. Okay. All right. Guess I'll put it over there, 395. So then we could calculate all the probabilities. What's probability getting 2 questions right? What's probability getting 3 questions right? We just use that little formula there. Or we could use the calculator. Calculator can do this for us. We're going to a new world. I like to call it Super Mario World. Super Mario Brothers. Remember the Super Mario Brothers go into a new world. We're going to go into a new world on our calculator where we can do a lot of stats stuff in here. Okay. So our new world is called distribution. This is called a binomial distribution. So press second vars. And it lists all kinds of distributions. There's normal distributions, there's t-distributions, there's chi-squared distributions. So I'm using the arrow key and I'm going down until I get to what's called a Binome Pdf. So this formula right here on our calculator, we could do a Binome Pdf. And we're going to head over to this place quite a bit. Again, how do you get there? You press second vars, V-A-R-S. So all we need to enter are 3 things. We need n. If you have Stat Wizard turned on, it actually does something a little bit different. It'll ask for the number of trials, which is n. Okay. Or what is n? N is on there. Okay. N comes first usually. P is probability, the probability of success, which is 0.25. And X is counts the number of successes. So X is whatever you want it to be. If we go back and do the first problem, probability X equals 5, we would just plug in 5 right there. If I want probability X equals 1, I'm going to do this. Calculator basically does this formula right here. Binome Pdf. N is 5. E is 0.25. Or you can put in a fraction, you put a fraction there, 1 out of 4, and X is 1. So I do Binome Pdf, 5, 0.25, 1, press enter, whammo, it does the formula for us, 0.395. Was everybody able to get there? Does anybody not have a calculator? You may not have one of these. I can hand it to you if you want. So I could do, I could go back. Put a 0 there. Put a 5 there. That'll give me these probabilities. If I put a 0 at the end or a 5 at the end. Oh, I could do 2. Put a 2 there. Binome Pdf. 5, comma, 0.25, comma, 2, 0.263. Put a 3 there. The form it's doing the calculator, doing the formula for us, 0.087. Find the probability of getting 4 questions right. 0.014. There's a 1% chance. That's 1 out of 100. There's about a 1% chance to get a 4 out of 5, which is the 80%. So again, we knew that was pretty unlikely to happen. It was unlikely to get 4 right or 5 right. We could do the same simulations for getting 10 questions right. Okay, if we had a 10-question quiz or a 40-question final exam. You're gonna take 40-question multiple choice final exam. Choices are A, B, C, D. With probability of getting a 25 out of 40. N is 40. X is 0.25. Or I'm sorry, P is 0.25. X is 25. And you get 25 out of 40. You calculate that theoretical probability. That's if you guess on every problem. Which pretty much proves that if you guess, you're not going to do very good. Okay, guessing. So that's why there's all these tricks for multiple choice, and a lot of high stakes tests have multiple choice questions. So one of the things you want to do is eliminate the bad answers. Okay, you know the answer if you're taking a probability quiz, and one of the answers is 1.7. I'm going to eliminate that. So now there's only 3 choices. My probability of guessing the problem correct increases. The chances increase. Was everybody okay doing second bars, going to distribution, going to Binome Pdf? Okay, what's this mean? This means binomial probability distribution function. So the calculator does a function for us. That's not really important. I'm not going to quiz you on that, the meaning of Binome Pdf, but it does it real fast for us. Okay. So X, again, X represents the number of successes. So I can find probability X equals 1, probability X equals 2, probability X equals 5, stuff like that. All these numbers right here, if I put these numbers in a table, last class, we talked about a probability distribution table. So remember, there's X was the number of successes. X counts the number of successes. Probability of X counts or calculates the probability of a success. So I'm just going to put these numbers in here. This table right here is called a binomial distribution table or binomial probability distribution table. So there you go. Binomial experiment. There's a binomial distribution table. So that shows all the probabilities. If I add all these probabilities up, I should get 100, right? Or 0.997 or something like that, because there's rounding for some of these numbers. We can make that table on our calculator. You guys want to see how to do that? Couple button presses, punching buttons. My uncle calls me a button pusher. He's like, yeah, that's what you do. You push buttons. You know, he worked on the oil fields, so I'm a button pusher. All right, push the buttons. You ready?
No.
Not yet. Okay. Okay, we're going to create this table in a list in our calculator. Our calculator will calculate all these probabilities for us with the push of a button. So I'm going to do this in a list, and this is not in the textbook, but I'm going to show you right now. I think it's really cool though. Press stat. Remember how to get here. Press stat, enter, and make sure that there's 0, 1, 2, 3, 4, 5 in list 1. If you have stuff in list 1, do not delete. Use clear. Okay, clear button will clear everything that's in list 1. So I got 0, 1, 2, 3, 4, 5 in list 1. I cleared list 2. So list 2 is clear. Sound good? Okay, I'm going to highlight list 2. So I'm going to go up to L2 and I'm going to highlight list 2. So this should be highlighted. Press enter. Now it says list 2, and now list 2 is flashing right here. So now it's saying, what do you want to do in list 2? In list 2, I'm going to do a formula in list 2. I'm going to do the binomial formula here in list 2. So I'm going to press second bars. And I'm going to go to Binome Pdf and press enter. So I got second bars. Go to Binome Pdf. And then it's the cursor still flashing. It says, what do you want to do? I want to put this information here. Okay, so N, what was N? N was the number of questions that we had. N was 5. Then I'm going to put in P. P is 0.25. Then I'm going to put in X. Okay, all the X values are in list 1. So this is a little tricky. This is when X is 0, this when X is 1, 2, and 3, and so on. So I'm going to put second 1 right here. So I'm going to put this 1 here. I'm going to put L1 in that space. And I press enter. And there's all those numbers. So the calculator did the binomial PDF formula. It is calculated this formula 6 times. And it filled in my list with all those probabilities. If you did not get those probabilities and you got an error, a DIM error or some other error, it's because you probably try to do it right here. You try to put Binomial PDF here, and it is trying to put all of those probabilities in this one spot. The calculator can't do that. So what we have to do is make sure list 2 is highlighted so we can fill up all the numbers in the list. Okay, so again, if you got an error, please raise your hand. I'm going to take a couple minutes to walk around and make sure everyone's on the right track, on the right page. So trials is 5. Well, I think, are you in the list right now?
No, because, yes, they will only.
Oh, so it's actually putting the formula right here. We want the formula right here.
Right?
I gotta do that, so I need 0.
your numbers.
Yes. we do.
Yeah. 19 million. So good one. Good. Show. Scientific notation is 9.7. So that's why I wrote it as 0.00. The three zeros. That's what would be. Anybody else? Yeah. All right. So we made the table. Once we got the table, we could answer some question. We could say, oh, find the probability x equals 3. 0.087, 8% chance of getting 3 questions right out of 5. It's not 3 divided by 5. 3 divided by 5 is 60%. Not a 60% chance of getting 3 questions right. It's an 8% chance of getting 3 questions right. And we can do this for any experiment that's binomial and happens X number of ways. Okay. So the book uses a binomial experiment. How do you access social media? Do you use a computer, a cell phone, a tablet, a game console, or the internet? Okay. Page 204 gives you that list, all those numbers in the list, 0.01, 0.07, 0.2, 0.28, 0.24, all those numbers, all those probabilities are the probabilities of each of those events occurring. What's the probability that 7 people use a cell phone to access social media? Okay, that would be 0.004 for 1,000ths. Okay, small probability of that happening. You could also use Excel. On Excel, it has it shows on page 205. We get page 205. Binomial.dist will calculate individual probability. So DIST means distribution. There's a mini tab, there's TI-84, and it shows Binome Pdf right in there, NP and an X. Okay, so we got NPX will give us the probability distribution. Let's do the same thing. Let's do the same calculation. I'm going to create a binomial distribution table for a 5-question quiz. But now the choices are A, B, C, D, E. Have you ever taken them? E, none of these. Those quizzes. Oh, driving bananas too. The probability of getting a question right is 0.2, or 1 divided by 5. Okay, this probability is 0.25. The probability of getting 0 questions right. On the probability of getting, let's go X 0, 1, 2, 3, 4, 5. So this probability was probably probability of success was 0.25. Over here, we're going to do probability of success is going to be 0.2. There's a 20% chance of getting 1 question right. Getting the first question right in 5 questions. So what if it's 10 questions? Then I would go all the way out to 10. So let's see if we can come up with these probabilities here like we did there. If there's a multiple choice with 5 choices, A, B, C, D, E. And you can still use the calculator like we just did to do it. Okay. You're just changing that probability, the 0.25 changes to a 0.2. Again, I could go back and do the formula for this if I really wanted to. I could do, let's say, right there, probably x equals 3. I could do that formula. So there's 5 questions. X is 3. That counts the number of ways to get 3 questions right. Okay, it's a pretty big number. I think it's like 25 or 50. There's 50 different ways that can happen. Probably success 0.2 raised to the x. Probably failure is 0.8. And notice 0.2 plus 0.8 is 100%. And then 5 minus 3 is 2. There's 3 successes, 2 failures. That's what the exponents represent. They represent multiplication. 0.2 times 0.2 times 0.2 times 0.8 times 0.8. That should give us 0.05. So with each of these, I could answer some questions about this. If I say find the probability x equals 3, this is the probability x equals 3. What if I ask another question like this? Find the probability. Let's go back to our first one. Let's just go right here. Find the probability x is less than 3. Find the probability x is less than 3. So what you're being asked to do is calculate this probability and this one and this one. Because that's where I draw the line. I draw the line at between 2 and 3. That's probability x equals 0 plus 1 plus 2. I gotta add all 3 of those probabilities together. That's just the notation. Yeah.
Real quick, how do we know when to round and how much decimals to round, like on the 3.2?
2 or 3 decimals. Yeah.
So we would.
If the answer was 0.409 and you wrote 0.41, that's correct. That's the same thing. 0.40962. Okay, it's just up to you. I didn't have enough space to write. I'm saving space on my board. But I mean, you got it on your calculator, should be fine. Nothing to worry about. Okay. If you're getting close to the right answer within 1/100th of a decimal place, then that's good. Okay. So that's the notation. What this says is add 2.237, 0.395, and 0.263 together. I gotta add them all up. So I gotta do those individually. I could do a Binome Pdf when x is 0 and then 1 and then 2, and I gotta add them all together. Or I can just punch it straight in the calculator, or I can use the shortcut. There's another shortcut. There's a shortcut for lots of things. I can do Binome Pdf. Okay. That one was right underneath the Binome Pdf. I don't know if you noticed, but when you press second bars, there was a Binome Pdf, probability distribution function. There is a CDF, cumulative distribution function. Okay, remember the cumulative frequency, remember all that good stuff, the C? Okay, so this is cumulative. So again, I'm going to put an N, I'm going to put in a P, and I'll put in an X. But what this does, this adds up all of those probabilities together. So I put in, if I put in a 5 and a 0.25 and a 2, Binome CDF, that will give me all 3 of these probabilities. Notice it says less than 3. We're not including 3. So you're going to see this word, it says inclusive. So if I say 3 inclusive, that's this. I'm going to include 3. This is not inclusive. This is not including 3. So probability x is less than 3 is exactly the same as the probability x is less than or equals to 2. So that's inclusive. So I go up to 2. It means the same thing. Okay. Find the complement, find the probability X is greater than or equal to 3. I gotta add these probabilities together. So if you see greater than, I could add these probabilities together. Or I could do 1 minus whatever I just got. 1 minus the previous answer. Okay. So that would be a greater than calculation. Again, it's really cool because the calculator does it for us. Binome Pdf will do that formula. Okay, CDF, cumulative, will add up a bunch of probabilities. The main problem students tend to have is, when do I use the P, when do I use the C? So we said probability X equals 2. That's just that probability right there. Probability X is less than or equal to 2. Oh, I'm going to add up a bunch of things together. That's cumulative. So I could use the CDF function. Okay, so cumulative CDF distribution function.
We don't count 0, right? Just 1 and
0 has a probability. So 0 has a probability. So yeah, we include 0. When we're adding up a bunch of numbers. Yeah, so 0 is part of, because remember in the original problem, find the probability of getting 0 questions right. That's a possibility. We'll learn about other distributions where 0 is not included. What's the probability of 0 of this happening 0 ways? An event that happens 0 ways, that cannot happen. Therefore, the probability is 0. But we'll see that a little later today. There's a cool table in the book that does all these things for us. Okay, so a shortcut for the shortcut for the shortcut. They speak about it on page 207. Page 207 has a snippet of the table. But the full table is not here. It's in the Appendix B, Table 2. So Appendix B. Table 2. It's a binomial probability distribution table. So somebody just made a table and created all the actual probabilities. All of these things, all these numbers are already in the table. So it's in the back of the book. Remember the table of random digits. It's right after the table of random digits. A7 is the table of random digits. A8 is a binomial distribution table. So A8. So how do we read it? The left side, all the way on the left, has n. So depending on your sample size, in our first original problem, n is 5. So I go down to n equals 5. Across the top, it has your probabilities. So I've got p is 0.25. So I go when n is 5 and p is 0.25, I go down until those two things meet. So I go down to, so n is over here, I go down to n is 5, and then my probabilities are on top. So I go over to 0.25. And where those things meet, you're going to see 0.237, 0.396. You see those numbers? What are those numbers? They're right here. Does that make sense? Okay, the only thing that the table does not have, it doesn't have the last probability. It doesn't have, oh, it says 0.001. So they rounded that last one, they rounded this to 0.001. But if you look just to the left of that, when p is 0.2, it says 0.000. So sometimes the probability can't be 0. Okay, we don't get, the probability is not 0. Probability of getting all 5 questions right is not 0. Okay. It says 0.000 because that's the nearest decimal. It's actually 0.0003. So this probability distribution table gives us all the probabilities that we need, but they can be found in the table here. Okay. Pretty cool. I'm running out of space because I got one more thing before I let you go. We've already erased this thing here. Because now that we saw that, all those numbers that I'm erasing right now, right there on the table, right, 0.20. Got all those numbers. How many questions would you expect to get right? Okay, what's the most likely event to occur? It looks like about 1. That's the largest probability. Getting a 1 out of 5 was probably most likely. Even though we had 10 people, we had more people get none of them right. But the most likely probability was to get 1 question right. So what's the mean of the distribution? The mean is called the expected value. And we learned that in 4.1, the expected value. Which is the mean. We got a formula. N times P. What was N? N was 5. P was 0.25. 5 times 0.25 is 1.25. So the mean for this distribution is 1.25, a little more than 1 question right. 5 times 0.25 is 1.25. So the mean for that distribution is 1.25. What's the variance of standard deviation? Okay. We get to find the standard deviation. Standard deviation. There's a formula for standard deviation as well. All these things, this is the last thing that's in 4.2. It's on the last page, 209. Standard deviation NPQ. Whenever you see Q, Q is 1 minus P. P is probability of success. Q is probability of failure. So you're going to multiply your sample size, which is N, times the number of successes times the number of failures. That gives you the variance. And then we square root to get standard deviation. To go from standard deviation to variance, you square. To go from variance to standard deviation, you square root. So let's do the calculation. Square root of 5 times 0.25 times 0.75. There's no shortcut for this on calculator. You just do the math. Second, x squared. Five times 0.25 times 0.75. 0.968. Okay. If you write 0.97, that's fine. About 1. The mean is about 1.25, close to 1. Standard deviation is about 1. So with mean and standard deviation, both are close to 1. So that will give me, which we're going to learn about in chapter 5, using the mean and standard deviation, we can come up with a normal distribution curve, the bell curve. We can use the curve to make a grade. If your data is symmetric, this is looks like it's skewed to the right or skewed towards the outliers. A 5 out of 5 would be an outlier. Okay. That would be unusual. Anything that's unusual on an unusual value, unusual point, abnormal, not normal. Okay. Getting a 100% guessing doesn't work too well. All right. So there's a lot of information. 4.3 is a lot shorter than 4.2. 4.2 is one of the longer sections here that we have. So a lot of information. The binomial distribution table, if you take a look at page 208, there's a table on page 208. This table is represented on page 208. There's a histogram. The histogram looks pretty symmetric. So if you have a symmetric distribution, you can apply the bell curve. Grade on a curve. Okay. If your data is normally distributed. It says about 60% of cancer survivors are 65 and older. You select 6 cancer survivors and find the probability that of each of these values. Okay. So there's probability distribution table. Again, you can make the table by using that little shortcut, put the data into a list. 0, 1, 2, 3, 4, 5. In this case, 0, 1, 2, 3, 4, 5, 6. So we have to put 6 on there and then do Binome Pdf. And it'll give us all those probabilities. Or hey, we could use the table. One thing the table does not have, it goes in increments of 5. So it has 5, 10, 15, 20, 25, 30. So if you're given a probability of like, oh, there's a 47% chance of something happening. 47% of the population has a tattoo, right? 47%. Well, I can't use the table. I can't use the table to come up with certain probabilities. There's 5 people. It's probably that all 5 of them have a tattoo, right? I can create a distribution on my own. Okay. All right. So you're good to go for probably about, I would say probably about 30 minutes to 45 minutes. Work on some problems, see where you can get. Do your best there. Move on to 4.3 later. Take a break, use the restroom, go for a walk. You want to go to Starbucks? I don't care. Just come back. There's other coffee places in town now. You don't have the Starbucks anymore. All right, so using those notations, we could use the binomialcdf. Binomialcdf will give us a lot of those goodies over there. So we got to understand the vocabulary, something I oftentimes struggle with, but hopefully it'll help. All right, any specific questions, homework, classwork questions, anything like that? Pretty tricky. It just takes some time to do a little practice in there. Remember the try it yourself problems, the chapter quiz, chapter test, chapter review. Those are all helpful as well. I also published a practice test. Time's flying. We're having fun because it's summer. We're already in chapter 4, and we're only in week 3. So we're gonna have a test coming up. How's it gonna work? We'll have a test first, and then we'll move on to chapter 5 material. Okay, so that's the plan for tomorrow. So I know it's coming up fast, and it's like we're just learning this stuff. It's all brand new stuff. Then we're gonna take tests on it. Well, that's cool. You learn it, test, so like that. I think I have quiz number 4. I think we're bypassing quiz number 4 just because there's not enough time to take the quiz. I'll double check that though, just to make sure. So binomial distributions, success, failure, and is fixed. We're gonna move on to another distribution. Well, actually, there's 2 more distributions that we're gonna study. This one's called a geometric distribution. Geometric distribution. So what's geometric distribution? This is when n is not fixed. So what's the difference? X counts the number of successes until the first success occurs. So we're going to do something until we succeed. Okay, or fail. Okay, so we can consider a failure when our first success occurs. There's a common question in the book. I think it says, we're selling refrigerators. Have you ever bought a warranty for a refrigerator or a microwave or any appliance? Has anybody ever done that or want you to buy a warranty? Nobody's ever done. I think if you buy a blender now, they ask you if you want the warranty on the blender. So they know that some of them are going to be defective. Okay, same with the television. Has anyone ever bought a television, went out after like a couple months, take it back to Costco, anything like that? I always see people with Costco's or TVs. I go through Costco, the the return line. There's always someone with the TV in the return line. I don't know what to do. Maybe they just buy it and watch the Super Bowl and then return it. I don't know what they're doing. But TVs could be defective. Cars can be defective. I have a friend that bought a car and drove it for 2 months, and then it transmission blew, the engine blew. It was defective. It's possible. So we're gonna purchase an item until we succeed, which means we'll find it something defective. So that's a common question that you'll encounter. Our first success would be getting a defective refrigerator. Okay, if you're working at Best Buy, possibility that you can have 10 refrigerators and one of them is defective. Okay, we sold a bad one. So we're gonna do something until the first success occurs. We're gonna do this with just for the sake of understanding. I'm not gonna get into defects and stuff like that and surgeries and some of the other things. I'm gonna do this with rolling a die. So if I roll a die, I don't know if it's DI or DIE. How do you spell it? DIE? You're gonna die. The dice.
Yeah.
How about a dice? Roll a dice.
Dice is plural, die is singular.
So I had it right. Okay.
Yeah.
So find the probability of rolling a 5. You ever play the Yahtzee game? Yeah, Yahtzee was a famous game in the 80s and 90s. You roll, getting a 5 or 6 is good. You want the big numbers because you that counts your points. Anyways, I want to roll until I get a 5. That's until I have a success. So the probability of rolling a 5, how many 5s are on a dice? There's 1 out of 6. So probability of success is 1 out of 6. If I don't roll a 5, that's called a failure. I have success and I have failure. Success means I roll a 5. Failure means I don't roll a 5. The probability is the same for each trial. So if I roll and I get a 5, that's probably that is 1 out of 6. If I roll and I don't get a 5, 5 out of 6. Roll again. The next probability is still 1 out of 6. The probability of getting a 5. I can roll 5 times until I get a 5. So we're going to calculate all of these probabilities. What's the probability of rolling a 5 in your third roll? Or your fourth roll? So we have probabilities for each of these events occurring. What's the probability of getting a 5 in 0 rolls? Okay, so this is 0. So there's not a 0. There's only a 0 with binomial distributions. Geometric distributions, we can't have the probability of 0 events occurring because the event has to occur first before we can calculate its probability. So a little bit different than binomial distribution. Again, X counts the number of successes until our first success occurs, which there's always 1 success. Okay, we fail, then we succeed. Find the probability of getting a 5 in the first roll. We just calculated that. It's 1 out of 6. 1/6. Which is 0.167. I could write it as a decimal. 0.167. Find the probability of rolling a 5 in the second roll. So I'm going to make a tree diagram here. The tree diagram, again, will help us. So a success is rolling a 5. Roll 5. It's 1 out of 6. Not 5. It's 5 out of 6. So in my first roll, probably rolling a 5 is 1 out of 6. I'm going to roll and I don't get a 5. Okay, that's this branch. Then I roll again and I get a 5 in my second roll. Well, that's 5/6 times 1/6. I just multiply, use the multiplication rule. The first roll was not a 5, the second roll was a 5. So that's 1/6 times 5/6. Which is 5 divided by 36. 5 divided by 36.139. Find the probability of rolling a 5 in the third roll. I don't get a 5. I don't get a 5. Then I get a 5. So I'm not worried about over here because I didn't say I'm probably rolling a 5 in the first roll and then not rolling a 5. Okay, that doesn't make any sense. So our first success, we're gonna do something until we succeed. So it's probably rolling a 5 in the third roll. That's 1 success and then 2 failures. I failed twice. I succeeded once. That's a failure. There's 2 failures. There's 1 success. So I multiply that out. 0.1157. Okay, the probability is getting smaller each time. And it's going to continue to decrease. Is it possible to roll the die 20 times until I get a 5? Yeah, that's possible. Pretty unlikely, pretty small probability of that happening. But there's a chance. There's still a chance it can happen. And we can find that theoretical probability. So again, geometric distribution. I got formula up there. How does that formula connect to what we are doing here in the tree diagram? Okay. Find the probability x equals 4. Let's do this one. Find the probability x equals 4. So I'm gonna use the formula right here for 4. Probability x equals 4. That equals p. And I'm just going to use fractions here. 1 minus 1 over 6. That's 5 over 6. Raised to the n minus 1. Well, n is 4. 4 minus 1 is 3. Okay. N minus 1. There are, if it takes 4 rolls, I have 1 success, I have 3 failures. There's 1 success, there's 3 failures. I can just calculate that out. Or there's a shortcut. There's always a shortcut. There's a formula called Geomet Pdf. We're going to put in there P and then N. We only need 2 things. There's only 2 pieces of information that we need. We need our probability of success, and we need the number of successes that we have. Well, there's actually only 1 success, but the number of times until it takes to get that success. So in this case, we're going to do this one here. I would do a Geomet PDF. P is 1 over 6. N is 4. And that should give me this number here. I'm going to calculate it. How do you find Geomet PDF on your calculator? Remember the Binome Pdf and the Binome CDF? Guess what? It's right underneath. And the shortcut to get there, I press second bars. And I actually use the up arrow key. Press up, and that takes you to the bottom. The second to last one, letter E, is Geomet PDF. Yep, 0.09645. Okay. Exact same answer. Exact same number. It does the formula for us. So then that previous question I had, I could use there's a CDF in there as well. Find the probability of rolling a 5 in at least 3 rolls. At least. 3 is the least number, so that's 3 or 4 or 5 or 6. I'm going to add all these probabilities together, or go 1 minus. Again, the probability of at least 3. On the probability of rolling a 5 in at least 3 rolls, so we can answer that probability. I know it's kind of silly to think of it like that, but probably X is at least 3, greater than or equal to 3. At least 3, so 3 or more. I'm going to draw a red line here. So that means I'm going to add all these probabilities together. The probabilities keep going and going and going and going. And they're going to be very hard to find. So one way to do that is go. Oops, I'm sorry, I did that wrong. Probability X is greater than or equal to 3 is 1 minus probability X is less than or equal to 2. Sorry about that. Bad notation there. At least 3, that's 3 or more. Or I can do these probabilities, 0.167 plus 0.139. That's about, let me do the math in my head, 0.4. 0.406 to be exact. About 40% chance of rolling in the first or second roll. Well, if this is 0.4, 1 minus 0.4 is 0.6. Oh, CDF. There's a CDF on the calculator. Geometcdf will give me those values. So, and P is 0.167, N is 2. Okay, so that should give me that 0.6 value. 60% chance of rolling a 5 in at least 3 rolls. So it's similar to the binomial questions you'll encounter, this geometric distribution. Very, very similar to doing that. So this table here, this table called probability distribution. We had discrete probability distribution 4.1. We had binomial probability distribution. This is called a geometric probability distribution. It's a table that allows us to find X and P of X. Again, we can make that table just like we did on the last. Okay, in this one, we're going to put in, oh, we don't even need 0, but 0 is already there. List 2. Again, highlight list 2. Well, first you want to clear list 2. Clear what's ever in list 2. Press the clear button. Don't press delete. List 2. And we're going to do a Geomet PDF in list 2. In this case, P is fixed. P is 1/6. X, all my X values are in list 1. Sorry, I wrote that really small there. So it says Geometpdf. P is 1/6. N was actually X. All my X values are in list 1. If I do that in my calculator, this list will get populated with all of those numbers. So try that real quick. Again, that's not in the textbook. That's kind of a shortcut that I have using the list function in our calculator will give us all those probability values. I'll do it real quick. It takes about 30 seconds. Clear list 2. Highlight list 2. Second bars. 1 divided by 6, comma, list 1. 0.1667, 0.139, 0.115, 0.096, 0.08, 0.08. I could add more numbers because it's going to keep going. There's N is not fixed for geometric distributions. Okay, so it just keeps going. Find the probability, again, 20 rolls. 20 rolls. If it takes, I get a 5 in my 20th roll. That means I have 19 failures. I have 1 success, but my first success happened in my 20th roll. So again, that's going to be a second bars. I go to geometpdf 1/6, comma 20. 0.005. Less than 1% of the time, it'll take 20 rolls until I get a 5. Again, there's a lot of application problems. Okay, a lot of ideas. This is not really a very good application of using a geometric distribution, just because it's really unique. Rolling the die doesn't really connect with too many things. Okay. If we could find each of these values, how many rolls would we expect to take before we get a 5? The expected value. Okay, that's the mean. So we're going to talk about the mean and standard deviation. We do it right over here. For a geometric distribution, the mean 1 divided by p, which is also known as the expected value, standard deviation. And these things they're not really in the book. They're not in the definitions until the problem set, which is on page 222. Standard deviation, the square root of 1 minus p over p squared. Page 222. So what's the mean? How many rolls would we expect to take until we roll a 5? What's our expected value? What's the mean? So 1 divided by 1/6, which is 6. There's 6 sides on a die, right? So if I roll it, I would expect to take about 6 rolls until I get a 5. Standard deviation. 1 minus 1/6 is 5/6. 1/6 squared. You might have to do that in parts. Might have to do this in parts. This is 5/6. And that part's 5/6. 1/6 squared is 1/36. We can do the math on that. It gives us, it's a number close to 1, I think. It's about 1. That is a geometric distribution. There's one more distribution that's unlike both of those. The binomial and geometric distributions all involve a probability P. There's another type of distribution that does not involve a probability and involves a mean. So if you're given a percent, you're going to use binomial or geometric distribution because this is the percent chance of an event occurring. The Poisson distribution, not Poisson, Poisson has 1 S. The Poisson distribution, page 217. It's got a funky formula. I'm just going to avoid the formula. It has mu and it has factorials and it has e raised to the negative mu. Actually, I'll write it down just for the sake of understanding. Poisson, not Poison. Poisson distribution, you're given the mean number of ways an event will occur. X counts the number of successes. Mu is the mean. Mu raised to the x. E raised to the negative mu over x factorial. That's the formula. So we need an example. We need an example of this. Given a mean, the mean number of ways an event will occur. Okay, if you're already given that, find the probability distribution. let's make a probability distribution table. Okay, so I'm gonna go ahead and make a table. I'm gonna give you an example. So let's say the mean number of accidents in a day in the city. I don't know, I hear sirens all the time. In a day in the city is 3. We average about 3 car accidents per day in the city. Does that make sense? Okay, we can apply this. Find the probability that there's no accidents in one day in our city. It's gonna be pretty small, huh? Find the probability of 1 car accident in the city. There's a probability of that event occurring. So you can see how this is slightly different than what we did here. This is given a probability. Now we're given a mean, and we're going to calculate the probability of an event occurring. So let's make a probability distribution table. X events. I'm going to use the same values 1, 2, 3, 4, 5. On the probability there are no car accidents. So unlike geometric distributions, 0 is the value. Well, how do I find that? I'm going to use formula. The mean number of accidents in a day in the city is 3. Find probably x equals 0. So we're going to use that little formula, find the probability x equals 0. We're going to use the formula to calculate that. X is 0, u is 3. Hey, there's a formula right there. Let's try the formula. Find the probability x equals 3. So I'm going to do the mean. I'm not going to put an equal sign here. Mean is 3. 3 raised to the 0 power times e. E is a fixed number. E is 2.71. I don't know how e was calculated in this formula. -3 over 0 factorial. Okay, factorial is a kind of a weird deal. In math, no two things are equal ever. But in this case, it is. 0 factorial and 1 factorial are both 1. We can't divide by 0. Okay. So 3 raised to 0 is 1. 0 factorial is 1. So all I gotta do is e raised to the -3 power. E raised to the -3 power. There's an E button on our calculator. How to find E? Okay. Second, ln. Just make sure you're on your home screen reader. Second mode. So I'm going to press second, and the ln button is underneath the log button. It's actually the inverse of log, or the inverse of natural log. E raised to the negative. Make sure you don't use subtract 3. Use the negative. The negative is actually underneath the 3. So I got e raised to the -3. That's all the math we're doing. 0.04978. I'm just going to round it 0.05. On the probability x equals 1. 3 raised to the first power is 3. Times e raised to the -3 power. Divided by 1 factorial is just 1.149. I just calculated probability when x equals 1. Let's do when x equals 2. Okay, forget the formula. Let's use calculator. That's why we had it. I'm not sure if you can do Poisson distributions in Excel. I'm sure you can. But we can do it on the calculator. Did you see it? When you press second bars, did you see this one in there? It was in between. Binomial came first. Geomet was at the bottom. Poisson was it right in the middle, right in between those two. So it's Poisson PDF. Oh, I'm all exactly identical to problem number 3. It says the mean number of accidents per month at an intersection is 3. Okay, so it's very similar to example 2. We put in mu in there, and then we put in x. That does the formula for us. So I'm going to do this. I'm just going to check for 1 right now. So I'm going to put in second bars. Poisson PDF. 3 and 3 is the mean. X is 1. 0.14936. That's exactly what I got. 0.14936. Did it mathematically with the formula, and I did it with the Poisson PDF right there. 0.14936. Find the probability of x is 2. Here's a shortcut. I got another shortcut. Press second and the negative sign. That recalls the previous answer. If you press second and the enter sign, it pops up my previous input. Second, enter. So I got to use the arrow key. I'm going to change the 1 to a 2. I just override it, just like a copy and paste in a calculator or in a computer. 0.224. Two more shortcuts. 3 more items for the day. We could do all this. This is called a probability distribution table. A Poisson probability distribution table. And I could do this in my list in the calculator. I can make a list. That. Enter. Hey, in list 1, I have those values. X is in list 1 still. There's a bunch of probabilities in list 2. I'm going to clear. Do not delete a list. If you delete, then I need to put it back for you. So if you delete it, please let me know. I'm going to clear list 2. So I highlight L2 and press clear. It says list 1 or list 2 underneath. It's flashing. Again, I'm going to highlight list 2. Press enter. This is the 3rd time we're doing this. We did it for binomial. We did it for geometric. Now we're doing it Poisson distributions. List 2 is highlighted. Second bars. Up arrow Poisson PDF. Mu is 3. Mu is fixed. The mean is fixed. 3 comma list 1. 0.04979. 0.14936. 0.224. 0.224. That's interesting. 0.168. 0.10. The mean is 3. Well, that's most likely if the average number of car accidents in the city per day is 3. There's 3 car accidents in our city. The average is 3. That's the most likely event to occur. The highest probability is 3. It's interesting that 2 and 3 have the same probability. And the reason why is because skewed right distribution, there could be 8 car accidents in the city in one day. There's a possibility of that happening. There could be 10 car accidents. The probability is going to be very small, but it still could happen. Okay, there's a chance that can happen. There's a theoretical probability that that would happen. So I'm calculating those values, and I did it in the table. I got all the values in the table. The table can keep going. I could just keep adding X values if I like. Page 219, here's a bookmark page. There's a big, huge table on page 219. I like it. I like it a lot because it helps me from being confused. This is the last time we use this book. Our school is ordering the 8th edition, so you probably won't be able to sell it to anybody ever again. Sorry. So you can write all over it. I wrote in my book, I've had this book for about 6 years. The first distribution is called a binomial distribution. I wrote the Binome Pdf formula in there. I wrote NPX. So Binome Pdf NPX in there. The calculator input. For geometric, it's the second distribution. I wrote geometpdf P, N in there. You could write it in your notes or you could write it directly in the book. That's fine. And finally, the last one is Poisson PDF. I put it at the very bottom. U and then X. U and X. Just like with binomial and geometric distributions, we could do a CDF function. Find the probability that there's less than 2 car accidents in a day. Less than 2. I add those two probabilities together. That's 20% chance. Well, I could use Poisson CDF. Okay, and I can answer a whole bunch of questions, just like we did with binomial and geometric distributions. Does that help? That table's pretty cool. And it gives you the definitions. It gives us pretty much everything we need right there in that table. I like it. I like it a lot. The questions are interesting because not all the questions are about geometric or Poisson distribution. There might be a binomial one in there. How do you know the difference? If you're given a proportion or a probability or a percentage, most of the questions come as percentages, then you're going to do a binomial or a geometric distribution. If it gives you a mean, Poisson distribution. Okay? So that's the difference between all of those. Pretty useful. Pleasure. Here's the table. Some cool person a long time ago made a table in the back of the textbook. In the appendix, there's a table of random digits. There's a binomial distribution table on A8, A9, and A10. A11. Look at A11. Poisson distribution table. So this table, the table is in A11 appendix, page A11. So again, here's how you read it. All the means are at the top. So we're talking the mean is 3. So I go until the mean gets to 3. That's really all we need. All we need to know is the mean. 0.0498, 0.1494, 0.224, 0.224. Hey, that's these numbers right here. So we could just use the table. We don't even have to use that list thing in the calculator. We don't even have to use Geomet.pdf because all the probabilities are in there. I should have showed that to you first before I did anything, huh? And the pages keep going. We could go up to a mean of like 16, I think. So there's 7.0, 7.1, 7.2. And the mean goes up to, looks like 20. Yeah. There's a mean of 20. So an average of 20, whatever it is, there's probabilities on there. Okay. Pretty cool. The mean is given to us. So if you're given the mean is 3, and there's a question that says, what's the mean? Well, 3 is given. But what's the standard deviation? You calculate the mean and standard deviation for binomial, geometric, and Poisson distribution. The mean is given. The mean is the mean. Standard deviation is square root the mean. So if the mean is 3, the mean is 3. What's standard deviation? What's square root of 3? 1.71. The square root of 3. So again, I wrote that. The mean and standard deviation formulas, going back to that page 200 and what was it, 220? 219. The mean and standard deviation formulas are in there. Mean and standard deviation for binomial. Mean and standard deviation for geometric is not in there. So I wrote it in. I wrote mean and standard deviation on page 219. Same thing with a Poisson distribution. The mean is given. The standard deviation square root of the mean. I wrote that in there as well. Okay. A lot of information there. Every day there's gonna be a lot of information in statistics. Learn something new every time you walk into the room. All right, great. Hey, it's 8:15. We got, you can stay here for an hour and 15 minutes if you need to. Otherwise, take a break. But I would suggest try to start working a little bit, get something done before you leave. Try to stick around for at least 15-20 minutes or so. That'd be great. Okay.
And then tomorrow is chapter 3 and 4.
Yeah, so if you walk in, it's gonna be on Canvas again. So if you walk into the room, I'll probably we'll do a review of questions. If you have any questions or concerns for about 20 minutes, we'll take the test. Probably take about an hour and 30 minutes to 2 hours. Part multiple choice, part free response. And then after everyone's done with the test, then we'll move on to chapter 5. There's a couple things about chapter 5. And so yeah, you'll probably need a computer tomorrow. I have a computer here. I'll bring my laptop as well in case something happens. You can't connect to Canvas. Any other questions? Pretty cool. All right. Yes. Oh, copy it. So I press enter. That's So that's Friday. That's Friday. So I made those things final. But yeah, that's. I'll probably do it. Oh, we have numbers in there. And I delete. It's still in my calculator.